So there is one word which may be troubling you a lot next in the almost on all the next classes. So first we better understand it in detail. What does that actually means? So this is the word you will be facing. So that word is called interfacing. Interfacing is not a typical concept, but if I give you a straightforward answer, like this, just like this word suggests, interfacing. There are two people standing, and their faces are in front of each other. They are just facing themselves. It may be the literature meaning of interfacing, but it's not like that. So what interfacing stands for? It stands for a physical connection. It stands for a physical connection. A physical connection of what? Physical connection of hardwares. So under hardware, what hardware should I consider which can be interfaced? That means physical connection of hardware. If this is hardware 1 and this is hardware 2, they will be connected by some phenomena, either this decoding, encoding, selection lines, or somewhere, somehow, two hardwares will be connected. So that physical connection of two hardwares will be simply called interfacing. But there are questions like which two hardware should be connected and when they should be connected, and is there any selection criteria? Because we know about a word, that the word which is called the compatibility error, right? You must have heard this at many times, that there is an issue of compatibility. Fine. So compatibility arises when there are two systems which are going to communicate or which are going to talk, but they are not able to talk. Are you getting my point? What a compatibility is? If the two people are not compatible to each other, they won't be able to talk. They won't be able to convey the messages. There is no proper understanding at both points. Fine. So that may be a compatibility error. Fine. That's why those matrimonial sites are too much advertising about the compatibility issues these days. That they have a compatibility check already before making matches. Anyways, that's part of a business strategy. So, while selecting the hardware, you need to think which two hardwares can I connect and which two hardwares cannot be connected in any situation. Fine. Now, let me ask you something. Have you ever seen a laptop or your desktop with multiple processors? This is a question, and I want answers on this. With multiple processors, tell me, have you ever seen a processor, laptop or desktop with multiple processors? Anyone? Any answer, please? Have you guys seen a processor with laptop with multiple processors? आया कोई मार्केट में
No,
कभी किसी
sir.
ने सुना है?
No, sir.
No, sir.
क्यों ऐसा क्यों इतने सारे कॉन्सेप्ट्स आ गए? Why we are not able to implement more than one processor in your laptop or desktop? एक से ज्यादा प्रोसेसर डाल देते हैं और फास्ट हो जाएगा. प्रॉब्लम क्या है? कुछ प्रॉब्लम हो सकता है एक से ज्यादा प्रोसेसर हो जाए एंड इट वुड बी ग्रेट. एक इंटेल का लगाते हैं, एक एएमडी का लगाते हैं. दोनों में कुछ कुछ खामियां है ना, कुछ चीज इंटेल के पास नहीं है, कुछ एएमडी के पास नहीं है. तो लेट्स कंबाइन बोथ ऑफ देम एंड क्रिएट अ बेटर प्रोसेसर, बेटर कंप्यूटर, बेटर लैपटॉप. ऐसा नहीं हो सकता? इजंट इट पॉसिबल? चलो ठीक है, कंपनी इश्यूज हो सकते हैं कि एएमडी विल नॉट अलाउ इंटेल प्रोसेसर टू बी एम्बेडेड इन एंड इंटेल विल नेवर अलाउ एएमडी प्रोसेसर टू बी एम्बेडेड, बट can't we create it? Will there be any problem? Logically सोचो, logically. Can we connect multiple processors on the same motherboard?
No, sir.
Why so?
Because सर माइक्रोप्रोसेसर एक तरीके से ब्रेन की तरह तो हो ना, कौन किस टाइम प्रोसेस करेगा, फिर उसमें तो दिक्कत होगी ना.
I appreciate your answer, but just a little louder.
Sir, it's just like a brain. Okay, so the
Yeah.
CPU will be having problem on which one should I process the each process on single process.
Even the CPUs will be multiple.
We don't have any space for that in a laptop.
Yeah, there will be a problem, but problem the way you are referring, CPUs will be multiple. It's not like a single CPU. CPUs will be working independently. They will be inside the microprocessor IC. But what actual problem do? I just want you to think like that, like a designer of a computer system, designer of this computing system. You have to think like that in order to understand what's the phenomena running in the background. आपको उस हार्डवेयर के डिजाइनर की तरह सोचना पड़ेगा. The way they think, and this is not today's time, this is 2021. The time is very easy in terms of technology. You can learn anything. This class is still running in 1978. We are still studying 8086 and 8255. अच्छा एक बात बताओ, इफ यू आर हैविंग ए फैमिली, आपके घर में दो लोग डिसीजन मेकर्स हो जाएं, ऑल्दो वी ऑल हैव अ कॉन्सेप्ट लाइक जनरली योर फादर्स आर योर डिसीजन मेकर्स, फाइन, बट likewise your father, let's say your mother as well, they both have a decision making, although they do have, and they both take different decisions. Let's say for your career, पापा कहते हैं मेडिकल करेगा, डॉक्टर बनेगा. मम्मी कहती है नहीं, ये सिविल सर्विसेज की तैयारी करेगा, ऑफिसर बनेगा. है ना? Are you getting my point? Why I'm pushing you towards
Yes,
the
sir.
thought process? This is the thought process. Every processor's design is different. They transfers the data in a different way. That means they will think in a different way, just like your parents. Your father has a different approach and mother has a different approach. They both has a different thinking. Fine, and the task needs to be applied in you. You are the object. Fine, तो पापा कह रहे हैं डॉक्टर बनेगा, मम्मा कह रही है नहीं आईएएस ऑफिसर बनेगा. अब बताओ ऑपरेशन हो क्या, क्या एग्जीक्यूट होगा? व्हाट विल बी द एग्जीक्यूशन? ठीक है, और
Confusion में रहेगा सर तो.
जिसको करियर बनाना है उसको पूछ ही नहीं रहा है. Are you trying to understand the situation? This is the situation everywhere. Because the designers have to think that way, the way we think in the real world. Fine. So if what if there are more than one processors running already or connected already in a system, they will have decision clashes. Definitely because they both have a priority setting inside. This hardware and this hardware, they needs to be connected in certain way. Fine. And you might have studied the concepts in the digital electronics. Fine. We were having a problem in which flip flop? JK flip flop. What was the problem we were having in the JK flip flop? The condition was race around condition, and the race around condition was recovered by implementing what phenomena? In JK flip flop, there was a condition that arise to a condition. Race around, कुछ याद है किसी को? Race around. Fine, and the race around condition was finally resolved by implementing the concept of master and slave. We connected two JKs and one was master, one was slave. Fine. Take the hint from that level that if even in the smallest level, at the level of gates and flip flops, they do need a master to derive another circuit. Fine, so there will be only one master even in the circuits. So how can I connect multiple processors? And processor is one unit which can actually control every part of the body or every part of the motherboard. Fine, and if there are two masters, there will be problems in the operation. So that's why the multiple processor concept is only for the parallel computing, where there are so many parallel processes in under execution, and they goes with the parallel computing phenomenon. That's a totally different domain which is called parallel computing. All right, so this arises the need for the this gives you the answer of the compatibility. What things can be compatible and what things are not compatible. Fine, so we have seen what are not compatible, and let's see what things will be or they can be connected. Okay, so in processors, there are few problems we have at the initial level, not at these days. At the initial level in the 1980s, we were having few problems like processors were not having few things on chip. So whatever I'll talk now, I'm talking about on chip that is available on the processor chip. Fine, and those things and these things were not available initially on chip microprocessors. So first one is and most important is the ports. Processors are not having any kind of on-chip ports. No. So in order to deal with the peripherals, I have to connect printer, I have to connect the display devices, LEDs, LCDs, and USBs, and these HDMI and VGA port, LPT ports. Many things I need to connect. Fine, but when I'm having no ports, that means there is no way the signal could be sent inside or outside. So how the peripheral will operate then? There is no way peripheral can operate. So the most important thing, we need to connect with the processor as interfacing. The first and prime is the port IC. We need an IC which can give us the ports so that peripherals can be connected. Okay. The peripherals can be connected. So first thing first, an IC which can provide us ports is the most compatible one, which is the most required one. Then there are few applications where we need timers, counters. Initially, processors were also not having the timers and counters on chip. They were not having. So we need that for some applications where timing is involved. We need to go according to the timing. Okay, let's say we create an application or a project where I'm asking you to automate the academic block according to the timetable of each and every class respectively. that all the lights should be turned on at 9 a.m. and they should be turned off by the sequence which is decided in the timetable. So we need a calculation in terms of real time. Fine. So that real time calculation can be done, but it has to be generated in a time sequence waveform. एक waveform generate करना होगा ना. So that's why we need timers and counters. So processors, when initially they were not having that on chip, so we need that to be connected. Fine. Next, the most important, memory. They do not have on chip memory, or if they're having, it's very, very small. So when we need to connect the ROMs and RAMs, they will be all external. They will be all external. Okay. Next is, that's why you have studied all those things external, PROM, EPROM, E square PROM, flash. That's why they are all externally connected. The processors were not having them on chip. If they would have been having them on chip, you will not be studying memory as a separate stream. All right, so ports, timers, memories, and there are few more things also. I may not be able to tell you those things right now, like DMA controller, communication ICs, which is called USART. USART stands for Universal Synchronous Asynchronous Receiver Transmission. You can note it down. Sometimes it comes in the quiz. USA stands for U for universal, S for synchronous, A for asynchronous, R for receiver, T for transmitter. And there is one more IC called UART. Fine. So things like this will arise the need of your interfacing. So this is what we need to understand, what we can connect. So what we can connect is the ports, timer counter. So let me write the IC numbers also. The ports, the IC which will provide us the ports is called PPI. That we'll be studying the first 8255. The number is 8255. The IC which will provide us timer counter, that is called 8253 and 54. Same. Memories, there are LS series or MS series. DMAs, it is DSC 430, I guess, and USART, UART are big numbers. Fine, so there are few ICs we'll be connecting. Along with this, I will also tell you how to interface LEDs. Fine, and your display units. Yes, display also needs to be connected externally. This on chip, you can't connect a display directly to the processor. That needs to pass through a separate IC. So along with the display, keyboard also. So there is a controller IC for both, which is called keyboard and display controller, and the IC number is 8279. 8279, yes. So these 3 or 4 ICs we'll study in the next classes. But before we go further, we still need to understand the concepts of interfacing. So if I tell you the 8255 interfacing card, and the IC that you are watching in the middle is the 8255. Fine. So that IC will provide the ports so that peripherals can be connected to the 8255, and then 8255 will transfer the control or a message to the microprocessor. You can see the jumpers or headers we are having on the left and right. The black jumpers, they are your connections. Fine. This is the 50-pin header and this is the 20-pin header. And these LEDs also. This is basically the interfacing card. This is for your experimental demonstration, and you can use it in the laboratory as well. So everything is connected to it, and these switches on the bottom, they will act like input, and the LEDs can act like output. So you can also change the status. There is no problem in this. You can individually use and create your own circuit. There's no problem. I just want to show you what are the interfacing ICs we have. And then we'll study about the pin diagram and all. This is their basic architecture and those things. Okay, let's understand in that way. Fine. So what I mean by interfacing, I'll demonstrate you in a better way the concept of interfacing. At one side, this is your microprocessor, let's say 8086. Fine. And this is your what? This is your peripheral. So let's say my peripheral is anything, it can be printer or something. So that peripheral cannot be directly connected to the microprocessor 8086. So we need something in between. Fine. So that something will provide what? That something is your 8255, which is called Programmable Peripheral Interface, PPI. So what 8255 is having? The 8255 is having ports. Basically 4 ports it is having. So what will happen? The peripheral will be connected to this 8255 first. Then 8255 will transfer the command to processor. Then processor will send the command back to this, and it will be loaded like this. So this is how the interfacing thing communicates. Fine. So basically the problem what you can be seeing, that this peripheral, this cannot be directly communicating, or this cannot be directly connected. It's not possible to connect them directly with the processor. They has to pass through this thing. So now you can see what is the concept of interfacing we are having. This is the place of interfacing where these two ICs are connected. This is the place of interfacing with where these two ICs are having the connection. Fine. So that's why interfacing is very important, because if these two are not compatible, there will be no data transfer. If these two are not having those compatibility, there will not be any data transfer. So everything has to be checked before connecting. Is this really required? Is this really required? Something like this. Or are we connecting the compatible ones? Or the generally the manufacturer of the ICs, they provide the list of compatible companies and the ICs what you can interface with this. Fine. So interfacing is something more than the physical interconnection. Although it seems like it is only the physical interconnection, but there are many questions which has to be answered in your mind, that what I'm connecting is perfect. It's not like I'm just connecting it randomly. It has to be perfect.